Section 9.5, Solving Quadratic Equations Using the Quadratic Formula. What we're going to learn about in this section is a really nice and convenient shortcut for successfully solving all quadratic equations. This is a formula that comes from completing the square with variables or unknowns instead of actual numbers for our coefficients. It's something we can look at in class to see how that comes about, but what we're going to look at here is just how to use the formula itself. So if we have a quadratic equation in the form of ax squared plus bx plus c equals 0, then we have our two solutions can be found using this formula right here. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. Now, there are a couple of requirements. A can't be 0, because if a is 0, then my x squared would disappear and I wouldn't have a quadratic formula. Also, b squared minus 4ac is going to be greater than or equal to 0. That's this value inside the square root, and we know that we can't take the square root of a negative, otherwise we'd have no real solutions. We'd have imaginary numbers. So that's just one of our requirements. We're going to look closer at that later on in the lesson. One way that people often remember this is actually by using a song, and so I will actually sing to Row, Row, Row Your Boat, the quadratic formula. The formula is x equals negative b plus or minus square root b squared minus 4ac all over 2a. So there you go. I'm not going to sing it again. You can hit rewind if you want to hear it again. Anyways, let's try to use this to solve the quadratic equation that we have in front of us. 2x squared minus 5x plus 3 equals 0. This would be a big pain to try to complete the square. It's not in the nice format where we can use the square roots. I guess we could graph it, but we don't want to have to do that. All we have to do is identify its coefficients. So a is the coefficient of the x squared term, which is 2. B is the coefficient of the x term, which is negative 5. And c is the coefficient, or I'm sorry, just the constant, which is 3. Now we set that up because it equals 0. That's the key. We have to have it equal to 0 first. Now I just plug into my equation. So I have x equals negative 5, because 5 is b, plus or minus the square root of b squared is negative 5 squared, minus 4 times a is 2, times c is 3, all over 2 times a is 2. What I need to do is I need to simplify here. Now, to start off, I've got negative 5. I can just write that as 5 plus or minus. And now I need to simplify everything that's in the square root first, my entire radical, before I start simplifying the radical itself. Negative 5 squared is 25, and then I have minus 4 times 2 times 3, which is minus 24. And that's all going to be over 2 times 2, which is 4. Now I can notice that my square root there becomes 25 minus 24, which is going to be the square root of 1 over 4. Let's give ourselves a little bit of space so we can continue with this here. And now I'm going to simplify that, because the square root of 1 I can say that that's 5 plus or minus just 1 over 4. Now, if that was a non-perfect square, I'd want to simplify the radical as much as I could, but this one works out. So because I have two numbers here that can be combined, I'm going to split this up into the two different solutions I want, which is 5 plus 1 over 4. And 5 minus 1 over 4. That's what the plus or minus really means. Well, the top one becomes 6 over 4, which reduces to 3/2. And the bottom one is 4 over 4, which reduces to 1. And those are actually going to be our two solutions. Those are the two values for x that will make my original equation true. And that's all we have to do. It's just really plugging in and working through the equation, just using arithmetic to simplify. So here's an example, or here are 4 examples. I've written the equation up at the top. what I'd like you to do is pause the video and try to do each one. I'll reveal them one at a time so that you can see that. If you get stuck, you can try it again, but I'll show all the work. So pause the video now and try number 1. Alright, let's see how it went. Alright, so you can check number 1 there. Biggest trick that sometimes happens for number 1 is the coefficient of the x squared. The a is a 1. If it's invisible, it's a 1 there. So that's what you'd have to do for that one. When you get down to simplifying, you end up with 6 plus 4, which is 10 over 2, which is 5, or 6 minus 4, which is 2 over 2, which is 1. Alright, now pause the video and give number 2 a shot. Alright, let's see how it went. Alright, so you can see here, even though we had a 1/2 involved, it ended up getting canceled out. We ended up with negative 1 plus or minus the square root of 21 over 1. Now, since that's not anything that can be simplified, I just leave it as that, and I don't need to write the over 1, so I can write my final answer as negative 1 plus or minus the square root of 21. Alright, pause it again and give number 3 a shot. Let's see how it went. Alright, so there you see we get a little bit more of a complicated problem. When we plug in, we get the square root of 88, which I could take a 4 out of there, and the square root of 4 is 2, so that's going to go in front. Square root of 22 can't be reduced any further. And then I just want to reduce. Now I notice that my constants here that are outside of radicals can all be reduced by a factor of 2. I have to do it for all 3 of them. Just like with a fraction that I'd seen before, I can only reduce it if it's with all 3. So I can divide 2, 2, and 6 all by 2, leaving 1 as a placeholder. I don't need to put a placeholder in front of the radical, and a 3 in the denominator. Now, in order to clean it up a little bit more, I even actually divided everything by a negative 2. That's why the negative 2 became 1 and the negative 6 became 3. Now when I divide the plus or minus 2 by a negative 2, it becomes minus or plus. It just switches around, but I can write them in either order. So that's why I leave it still as plus or minus the square root of 22. And that's my final answer there. All right, one last problem. So pause the video and try out number 4, and then come back and check your work. Okay. Did you remember to do the first step, which was to add 1 to each side? If so, let's move on. Alright, so with this example, what ends up happening is when we plug in, we first have to move the 1 to the other side, because we have to get the equation to equal 0, and that changes it to a positive 1, which is going to make a big difference here. When we plug in, we end up getting 4 plus or minus the square root of 0 over 8. The square root of 0 is just 0, so adding or subtracting it doesn't make a difference. So I'm just going to still have 4. So I have 4 over 8, which equals 1/2. So this is an example where I actually have one solution. We've seen that before with when 0 is involved. And so that's a bunch of practice using the quadratic formula. Alright, let's try to apply the quadratic formula in a real-world context, and something that involves a word problem here. I'm going to take an object and throw it from the top of a 100-foot building with an initial upward speed of 20 feet per second. Its height, in feet, above the ground after t seconds can be modeled by the equation h of t equals negative 16t squared plus 20t plus 100. After how much time will the object be 50 feet above the ground? So what we're looking to do here is we're looking to use the quadratic formula to solve an equation. We want the object to be 50 feet above the ground, so I'm going to replace the height, h of t, with 50. And that's going to be equal to the rest of my equation, negative 16t squared plus 20t plus 100. And now I want to solve an equation, but in order to solve it using the quadratic formula, I first have to get something equal to 0. So I'm going to take this 50 and subtract it so I can move it to the other side. When I move it to the other side, I have 0 equals negative 16t squared plus 20t plus 50 because of the 100 minus 50. Now this is set up so that I can use the quadratic formula. I know that A equals negative 16, B equals 20, and C equals 50. So what I'm going to do is I'm going to plug in to my quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac. So when I go to plug this in here, my negative b is negative 20 plus or minus the square root of b squared is 20 squared minus 4, a is negative 16, and c is 50. Little tight here. I'm going to scroll over just a little bit so I can fit that in. There we go. And we're going all over 2a, which is all over 2 times negative 16. So, do a little bit of calculator work. Do 20 squared minus 4 times negative 16 times 50. And we're going to get x equals negative 20 plus or minus 3,600, the square root of that, all over negative 32. So from this, I actually take a look and I see, can I do the square root of 3,600? And as a matter of fact, I actually can. Because the square root of 3,600 is just 60 squared. Now, if it didn't work out nicely, we'd want to use a decimal approximation probably, or at least a reducing this. So let's give ourselves a little bit of space to work with here. We're looking at x equals negative 20 plus or minus, that's going to be 60 all over negative 32. And because that's the square root of 3,600. Now at this point we're going to want to split it up, and we're going to have negative 20 plus 60 over negative 32. Negative 20 plus 60 we know is 40 over negative 32. And 40 over negative 32, I could reduce that to make that negative, and divide everything by 8 to get negative 5/4, but it probably would make more sense to think about this as negative 1.25 seconds. Now, I used x because that's what the quadratic formula is, but in this case I'm really talking about a time here. So time equals negative 1.25. Now, my other answer would be using the minus. So I've got x equals negative 20 minus 60 over negative 32, which is negative 80 over negative 32. And 80 over 32 would reduce all the way to dividing by everything by 16, and the negatives cancel out. We'd go all the way to 5 over 2, or 2.5. And again, this is measured in seconds. Now, we've got two answers, but we only want one of them. Because we're talking about time, we can't have negative time. So negative 1.25s really doesn't make any sense. The answer that we want is 2.5 seconds. What the negative 1.25 would be is instead of throwing the ball upward, if it was moving backwards, when would it go back to being at only 50 feet above the ground? That's why it would be negative 1.25 seconds. Instead, it's going to go up, come down, and that's going to be the value that we want, the 2.5 seconds. So, to answer our original question, after 2.5 seconds, the ball will be 50 feet above the ground. All right, hope this is clear. All right, now it's time for some practice. Basically, we've learned 4 different ways to solve quadratic equations. We can graph them, we can factor them, we can use completing the square, we can use the quadratic formula. Graphing is sometimes a pain, and so I don't want to try that now, but I want you to look at these 3 options here and solve them any way you want. So pause the video, give it a try. You can come back and check. I'm going to solve them 3 different ways. I'm going to complete the square for the first, I'm going to use the quadratic formula for the second, and I'm going to factor the third. So you can try all those out and come back and check your work. Alright, so there you go. There are your 3 problems worked out. You can pause the video to check the work. Used completing the square for the first one, quadratic formula for the second one, and factored the third one. The first one is not factorable, but the last 2 were. Completing the square would work for any of them, as would the quadratic formula. So just check your work, see how you did, and hopefully you feel confident going forward with problems like this.